Why can a solid magnet sitting still on your desk somehow reach out and drag a piece of iron across the empty space towards it? In the energy filament theory, the whole universe is a sea of energy that can be tightened and patterned. Magnetism is not a new mysterious force layered on top of nature. It is simply iron sliding along a smoother road that the sea has already carved between them. In this view, the universe really only cares about two kinds of slopes. One is a tightness slope, where the sea changes from loose to tight, and gravity is just things sliding down that difference in tension. The other is a texture slope, where the road surface of the sea changes from rough and tangled to smooth and well-aligned. And electric and magnetic effects are really motion following the path where that texture is easiest to move through. Magnet-iron attraction is pure textured slope. Inside a magnet, many electrons have their tiny ring currents. Their magnetic moments, pointing almost the same way, like a field of wheat all bent in one direction by wind. Those aligned internal swirls carve a very clean rotating pattern into the sea, a preferred direction that runs all the way through the magnet. Iron is special because some of its electrons carry magnetic moments that are partially free, not locked rigidly into random directions. They are like stalks of grass that are already leaning a bit and are easy to bend further. When iron comes close to a magnet, the smooth swirling texture in the sea around the magnet gently twists those half-loose moments inside the iron, so they line up more and more with the outside pattern. As more little loops turn, the texture in the sea between magnet and iron stitches together into one continuous corridor of aligned swirls, like two separate paths that merge into a single highway. One end of this corridor lives deep inside the magnet, where the pattern is strongest and most orderly. The other end grows down into the iron, where the pattern gradually fades into a mess of misaligned directions. For the iron as a whole, that joined corridor means the sea around it now has a textured slope. On the far side, the roads are broken and full of dead ends. On the side facing the magnet, the roads are straight and smooth, like a dredged shipping channel cutting through rocks and eddies. The cheapest thing for all the tiny disturbances in the sea to do is to push the iron towards the smoother side. So bit by bit the iron slides along that corridor until it touches the magnet. And to your eyes it looks as if something has reached out and pulled it in. A more everyday picture is wounds on grass. The grass does not decide which way to lean. It simply bends wherever the air can push it most easily. The iron does not decide to move either. It is nudged along the direction where the texture of the sea makes motion lose the least energy. Materials like copper, wood, or plastic hardly respond because their internal electrons do not have magnetic moments that can easily twist into the external pattern. Their wheels never drop into the rails of the track, so even a strong outside swirl fails to lock them in. Iron, nickel, and cobalt, by contrast, have many moments that can turn and latch onto the corridor. So they are the materials magnets most easily recruit. In this same language, magnetic poles stop being mysterious stickers and become the two ends of the main texture channel. At one end, patterns in the sea mostly dive into the material and circulate inside. Like water streaming into a drain, that is what we call the South Pole. At the other end, patterns mostly emerge from the material and fans back out into the wider sea. Like water jetting from a pipe into a pond, that is what we call the North Pole. So when you say the magnet pulls the nail, you can swap that sentence for a more physical one. The magnet organizes the energy sea into a very smooth corridor, twists the nail zone easy to rotate ring currents until they join that corridor, and then lets magnets and iron roll together down the shared, low-resistance path that the sea prefers. Tap follow, share it on New Physics, Clear Universe.